Alright YouTube, this is part 3, sorry, of the battery EX02 12-48 400 test. So this is the inverter I'm going to be testing on the battery bank right there. So this is a 1500 watt Kotech 24 volt pure sine wave inverter. Alright, well, this is how it looks like, folks. You got a deep switches. You can able to adjust different settings right there. That will be on the next video. I will show you how that device work. So 1500 watt Kotech pure sine wave 12 volt inverter. Here are the specs right here. The input is 21.0 to 30 volts. Over voltage DC is 30 volts is 90 amp. This inverter can take 90 amps. Alright, go about it. And this is what it is, folks. It has a huge fan on the back. It has a remote RJ11, like a telephone port. So this is not like a RJ45 like Ethernet. This is like a telephone. That's for the remote. So I have the two screws bolts right there, and these are the protecting covers that goes there for the battery terminals. But because of I'm using a bigger gauge wire, folks, so it's not gonna fit in there. So this is the wires I'm gonna be using. The wires are these ones. If you can look at it, it's a Royal Excellence. It's a 2-gauge welding wire. 2-gauge wire. Alright folks, this is what I'm gonna be dealing with here. Right here with the Kotech. And please stay tuned for the test. I'm trying to wire this one together, put everything together, and connect the wires to the inverter and get it ready to connect them to the battery. Alright, the battery's already wired on the path 2, and I'm gonna be wired the inverter to the opposite terminal of the batteries. Stay tuned. Alright guys, the inverter is already wired, and you guys can see both the positive and the negative cables, and they're all the same length. But I'm gonna give you a measurement here, the length of this wire, because the length matters as well. If you installing an inverter, and see, the wire don't have to be that long because of efficiency. So hold on. Alright guys, if you look closely, you'll see it is approximately 2 foot long. See that right here? So it's about 2 foot long. See, that's it. So it's getting right there to the inverter and all the way to the battery. See that? So you don't want it too long, so you can lose efficiency. So your inverter is going to be really efficient. So this is the way I'm gonna have this battery extra. The battery extra is gonna be connected with it on the other side of the battery and get the system going. Alright, stay tuned. As you guys can see, I'm trying to put the charger just to prove it to you guys. It's almost about 1 amp left for it to be like a complete charge. So the needle has to go into 0 to really tell you that the batteries are 100% charged. So you see the needle sitting at the first stroke after the 0. So it's just about an amp left. Just to prove it to you guys. So here are the batteries when the charger is connected into it, just to show you that the batteries are almost full. So a little bit left for us to call it like a complete charge. But you guys saw the testing I did on the part 2 that the batteries were 13.5, the other one is 13.6. So when I started this process, I can only have one battery, which is the good one right there, number 1 good. It gives me a reading if I charge it, it's giving me a reading of 13.6, and the other one was reading 12.8. So it's working. Desulfator is working. The inverter is sitting right here. I'm going to be connecting that, and you guys will see. And desulfator is here. I'm going to be connecting that as well, so you guys can see the performance and see how this device work, since this battery's already been on the desulfator for 3 days. Just 3 days to see the impact. You guys already seen the impact on the batteries. Okay, stay tuned. Alright folks, this is the setup right here. The desulfator is back. The inverter is connected. You see the wires. It's a 2-odd cable. Sorry, 2-gauge cable. And the one that join the batteries together for series 24 volt is a 2-gauge wire. And the one that draws back to the inverter. So I separated them over there so they can't touch. So is 2-gauge wire. So folks, I'm gonna be doing the test. I'm gonna put the kilowatt meter and see how this thing is gonna handle the stuff. All right, take care and see how long we're gonna pull these batteries till the water boils on the tea kettle. Then we can get from there. All right, stay tuned guys, and I'll be right back. jwsolarusa, stay tuned. All right folks, this is the setup right here. I already have the batteries all connected. So this is the series right here. Connect the 2 batteries, 2 12-volt batteries to a 24 volt. And I got a desulfator from there. Okay, 2 connected to positive to negative makes it 24. You connect it from one end to the other one. That's how you connect a 24 volt battery and goes to the inverter. There's the inverter cable all the way to the inverter. The desulfator is connected right here to the positive terminal, and you guys can just see the desulfator is showing a 28.3. That's the battery voltage. And I have the Cotec 1500 watt 24 volt pure sine wave inverter. I have if you guys can see, I have a kilowatt meter, and I have a 1500. See, I can show you guys. I don't know if I can able to grab that. You guys can read for yourself to make this really easy. I hope I can hold it steady. Oh boy, see that? 1500 watt. There we go. 1500 watt tea kettle, 120 volts, 60 hertz. So I have a liter, 1.5 liter. So we're gonna start the process here soon, and you guys can see how these devices can handle the batteries. Okay, if the batteries can handle this stuff. So we got this plugged in. So folks, we're gonna have it on watt. So now the inverter went back to sleep, and we're gonna put the tea kettle on by turning the switch right here. There we go. See that? Oh, here we go. 1430 watt. Oh boy. Come on, camera. So here the batteries are sitting at 24.2. It's doing this thing. Let's keep watching the batteries. And see that? 1432 watts is pulling. Let me show you the amps. 12.12, 12.12 amps. Look at that. Here is the hertz. 50, 60 hertz. Voltage 118. Amps 12.12, 14.33. So the batteries are holding pretty good, folks. The batteries are holding, and the water is about to get in there, trying to get boil. It's boiling, folks. The device is working. It's working, folks. We have 24.1. Remember, these batteries are 55 amp hour each, and it's connected in series. So if you connect them in series, we are not increasing the amperage. We're subtracting the amperage while increasing the voltage. So the amperage right now, the amp on that battery, these two batteries end up being only 55 amp hour battery instead of 110 amp hour battery. So it's just one battery is operating now. It's like a 55 amp hour battery, and you guys can hear the noise coming out from the tea kettle. Oh boy, it's getting hot. Look at that. Look at that. Desulfator is working, folks. It's working. 1420, 1428. Look at the amps. 12.09 amps. Device is working. It's working great, folks. The desulfator is doing its thing. The battery extra EX02 1248 400 is working. Folks, the water is boiling. The water is boiling. 24 volts right now sitting on the battery. Will you imagine? It's just like running one single battery. Just like running one single battery. 55 amp hour battery bank. 55 amp hour battery bank is still working. Folks, you guys can see the specs right here. See WKD C1255B. Yes. Yes. The desulfator is working. Skeptics, this is a proof again to you. 100% proof. Look at that. I just dropped to 23.9. The water is gonna boil right away. In few seconds, the water is gonna boil. We still have voltage on the batteries. Sorry, folks, I don't even have a amp meter hook up to this stuff. But look at that, folks. The water is about to boil. 15 minutes past the hour right here. You can see 15 minutes we already done all this test. Kotek is sitting down doing his thing. We just have a light right there showing you guys. So it's going down past the 12 volt. Oh, sorry, the 24 volt. Look at that. The wattage, folks, the wattage. Sorry, I can't focus that. Look at that. Look at the steam. Steam is coming out. Oh my God. Steaming. Yes. Yes. Shut off right away. It shut off. 1500 watt into 1500 watt inverter. 1500 tea kettle, 1500 tea kettle, 1500 pure sine wave Cotec inverter. Best machines. Best proof right here for the skeptics and people that deny stuff that is not working. Not for JW Solar USA. JW Solar USA like to prove things. I like to test things. Now you guys seen the process. Here we go. 26.1. The battery came up, went up again. Sorry, and this is the show, and this is the test. So, folks, the inverter already went to search mode again. See that flashing? That's what it does. Yeah, went down. See, no power. This inverter saves you from phantom powers, like drawing unnecessarily power without any load. And this device is just awesome. That's why I love that Cotec, and it's my backup. It's my backup. If anything happened with my 48 volt right here, this guy right here, ha! Yeah, Cotec is gonna step in right away. 26.2 volt, folks. 26.2 volt. Look at that. System is awesome. So my point is, folks, point of argument is some people don't just believe that this battery extra, the EX02 1248 400 or desulfators doesn't work. That's what people think. A lot of people think the desulfators are not working. Maybe it's the one that you just buy or the one that you purchase, but my desulfator, which is the battery extra, works. 3 days on these batteries, just 3 days. One battery was reading, if I charge them, one is holding a 13.6 and one is just holding a 12.8. 3 days into the desulfator, you guys saw when I made the first video, the first test. And now I proved myself. I already proved it to you guys. So this desulfator staying here forever or staying there permanently is gonna get these batteries back to brand new. It's not brand new, but it's gonna probably bring them about 90%. I wasn't able to use an inverter onto those batteries. I put those batteries only for lighting. And now it takes 1500 watts. Okay? 1500 watts, which is 14 point something, 1424 something. You guys can rewind the video and see. And it's taking 12.12 amps. That's a lot of amps it's taken from the battery. 24 volts. Would you imagine if that was a 12 volt? Man, that would have been like a 24 point something or maybe 25 amps. But 24 volt works. 12 volt system works. 48 volt system works. Any system that you have that works for you is your system. Anything you're happy with is your system. All right, this is just a test and just a proof for you guys. This is how we do it right here at the JW Solar USA. This is how we test stuff, and this is how we prove things to people that are really skeptical about certain machines. I can only do a review on machines that I own. I don't just talk about things or machines that I think, oh, well, I just purchased that. I have to try it for quite a while before I put it in a video, because I don't want people to, because they will take my word and go ahead and buy this device and end up failing me. Trust me, if this device doesn't work and it stopped working today or tomorrow, folks, I'll make a video again and tell you guys this device failed me. The device stopped. But That's why I'm proving it to you. The device works, because I already have some messages that if this device really work, because Desulfator doesn't work. Some people are saying that, oh, I can build my Desulfator too. Some people know how to build theirs, but this one came from the Great Britain, our great allies in Europe. They made this device. We have the battery savers, Desulfators for the US, and different kinds of them. And this is just what I got. And check on YouTube. You can see some videos on this one. And I just want to show you live in America and how I'm testing mine. And since I got them, and you guys can just see how the system is working. The system is working great, great, great. So this is going to be just a little system with the wires. Remember the first test, and the wires I demonstrated, those are just 6 gauges, and these are 2 gauge wires. Because I know the skeptics were not saying anything, but the thing is, I told them it's for demonstration purpose only. But now I use the actual wires. The length, I gave you guys the measurements on the video, is 2 foot long. Okay? For the wires from the inverter to the batteries. You know, it's the same thing. The one that series that is a 2 foot long. It's supposed to be shorter, but this is, I don't want to cut those wires because they are here for demonstration purposes, and I have to reuse them or recycle them again. So I don't want to destroy the wires for just tests like this. So I use the 2 foot, and this is perfect, brilliant, awesome test from Minnesota. JwSolarusa, the land of 10,000 lakes. You have a good night. And final test. Don't forget to subscribe, like, and share. Share with all your loved ones and your family and all YouTubers and all the media, social media. Let's push it one more time to start up this thing again and see. Here we go. Just to keep that water boiling again. Just watch it, the skeptics. Yeah, don't be skeptical, folks. Do it. Do it yourself. Here's the batteries. Here are the batteries. 23.8. You see the steam coming out? Here we go. That baby is boiling. Yeah. Yeah, I'm not wasting that water. I'm gonna make myself a nice tea. Nice tea. That's right. 23 minutes 47 seconds for this video. Look at the tea kettle shaking. I love it when things always work right. When you do things right, they work right, you're so happy, you're so excited, just like a little kid. And this is how it is. The system works. Back to the voltage, 26 volt. All right, guys, I love you guys, though. And take care of yourself. JwSolarusa. Bye for now.